So now we're going to be continuing in login data changes in Entity Framework. Now last time out we created the entities and the DB context for our applications as well as the database. This time around we're actually going to put that into practice and create an ASP.NET Core MVC API to actually test out the logic. Now before we do that I need to create a couple of services. I'm going to create a base service, which is an abstract class which will have all our CRUD methods. So our create, read, update and delete. I'm also going to have a BaseChangeService, and this is going to basically inherit the base service, and there's going to be some overriding of methods, particularly with the create, update and deleted. What the override is going to do is actually put in the functionality to log the data changes. Now if you wish to download the code or the database for this example, you can do. There's a link on the screen for you now. So let's go ahead and look at our example.
So now we're going to have a look at the BaseChangeService class. Now this BaseChangeService class is going to hold all our CRUD operations for our entity. So what this is doing is that it's inheriting this base service. So let's have a look at the base service quickly. So if we look in here, we've got our read method there from our entity. We've got a create one there, update and deleted. Now the whole point of the base change service is that we're going to actually log our data changes, so we need to override some of the methods. But before that, I'm going to talk you through some of these generic types that we've got up the top here that we're passing through. So you might see here that we've got a couple of DB contexts that we're passing in as generic types. Why are we doing that? Well, it's when we come to our test-driven development, we can create separate DB contexts using in-memory, which basically means it doesn't communicate with the SQL Server. That basically means we can set up a separate DB context when we're doing the testing and when we're testing this service. We're also passing in a T entity as well, and as you probably have guessed, the T entity inherits the iChange entity. So an example for this is back in part 1 when we looked at the video game record, which we can see here. It inherits the iChange entity, and as you can see, T entity is of class of iChange entity. So now we're going to have a look at some of the methods inside this service. We're going to have a look at this getChangeData. Now this getChangeData is used in pretty much all the methods that we're overriding. We've got this ChangeData class, which we looked at in part 1, and that's basically going to store all the changes that we make, and it's going to log all the data changes. We're also passing in this entity entry class from Entity Framework, and this is really good because basically it will track all the changes. So it gives us a log of all the current values, and if we're doing a modification of the record, it'll give us the previous values as well. So we're going to call this populate change properties. And what this is doing is it's basically going through each property and seeing what the value is. And if it's modified and it equals, then we remove it because we don't need it at that point. But it will basically create a new property with the actual value. Now going back up here, we're running it all the time for the current values, but if we're modifying an entity, we also want to do it for the original values as well. And that's a really good thing about Entity Framework, is that it stores the current and original values. So let's now go and see what's happening in our create method, our create async method. So we're creating a new instance of ChangeData. We're adding the entity to context. So this inherits from the base service. It's basically using the data DB context and adding the entity. Then we're calling our getChangeData, so we have to call this in between adding the entity and actually saving the changes. That's because the actual current values disappear once it's already been saved to the DB context. We then call our SaveChangesAsync. Again, this is inheriting from the base service, and it's just basically calling SaveChanges. Then we've got this other method down here called CreateChangeAsync. So let's go into that. Go to the definition, So yeah, this is looking at an instance of our ChangeData. It's making sure we've actually got some properties to actually add in there. And it's basically using our change DbContext. It's adding the entity to it, and then it's saving the changes. So that's the create. The update works slightly different. We pass in an entity and an ID, but then we do a read async. So we get the ID from entity framework, or we get the entity from entity framework based on the ID. Assuming it can find it, it then basically gets that record and sets the values from our update entity. Now this update entity is not being tracked in entity framework, and this set values here makes sure that it does, but it's only going to update the values that we've actually updated, because we don't want to be overriding data that we haven't changed, particularly if it's been changed by another application. We then go through, mark it as modified, we call our change data again, and assuming any of the properties have been modified, we go ahead, save our changes, and create a change record. Lastly, we've got our delete async here. This is actually overriding the delete async method on base service. We're actually doing a soft delete here, so we're setting the deleted to a timestamp, actually setting the state to modified, and then saving the changes. Once again, we're creating a change record so we can log that it's actually been deleted, and we can log the sort of time that it's been done. So to integrate all of this together, we need to inherit the BaseChangeService into another class. The reason being is that the BaseChangeService is an abstract class, so we can't create a new instance of it. So what we've done in the services is that we've created a VideoGameService. Now all this is doing is it's basically inheriting the BaseChangeService, and we're passing in our DbContext. So we've got the data DbContext and the change DbContext. We're also passing in the entity of VideoGame. So the nice thing about this architecture is the fact that if we had separate entities, we could do the same thing here. So we could create, I don't know, an engine service. All video games are based off an engine. We could create an engine service, and it could use an engine entity there. And there's nothing happening here because it's using all the methods in the BaseChangeService. But if we wanted to add additional methods into the VideoGameService, we can do. Now let's go into we've created a web API to test this out. So let's have a look at that. If we go into the startup configuration, I've added the services here. What this is basically doing is it's basically adding the video game service via dependency injection, so we can actually use it in our web API. Now we've created a couple of controllers, and this uses a similar architecture to how we've done the services. We've got this BaseController here, and this has basically got all our read, create, update, and delete methods. We've also got this BaseChangeService as well, and again, this is just basically inheriting BaseController. And lastly, we've got a video game controller. That's got a root set to API/video-game, and that's inheriting the BaseController. Now we can go ahead with Postman and actually test to see if this actually works. So now we've got our web API running, and what we want to do is we want to use Postman to actually test the methods inside our video game controller. So we're going to open up Postman now. Now most importantly with this, we want to make sure not only is it communicating with the SQL Server for our entities, but also it's logging the data changes. So in this method here, we've got a create, which we're going to test the create method. So let's go ahead and do that. So as you can see, the server's returned a 200 response. It's passing back the entity, and it looks like we've got all the information that we need. Let's just make sure that we've got it in the SQL Server. So let's update our video game table. And yes, as you can see, we've got the title, publisher, and gun media. Now, more importantly, are we logging the data changes at this point? If we ever make any changes to this video game record, we want to make sure that we know what the values were for each of the properties when the actual entity was created. So let's see if that's happened. As you can see, it's happened. We've got reference ID there, which corresponds back to the video game ID, which is 1. We've also got a created timestamp, so we know when this record was created. And we've got this ChangeData here, which is basically a JSON formatted string. As you can see though, it's all been minified, so we really need to prettify it to see what values have been stored. So let's go ahead and do that. So as you can see here, we've got our properties down here, publisher, release date and title. So that's all good. But we've also got these other properties as well, which first of all are wrong and also we don't really need. So in part 3, what I'm going to do is I'm going to show you how we can go ahead and actually ignore properties that we don't need. We certainly don't need the ID because we've already included it in the reference, and we don't need the created either. And the deleted is going to be used in a different way. It's going to be stored in the ChangeData. So we'll come on to that in part 3. Now for the rest of this, what we're going to do next is we're going to update that record just to make sure that it only stores the values or the paths or the properties that we're actually updating. So in this instance, we're updating the title from Friday the 13th of the game to Friday the 13th. Let's run that. So we've got a breakpoint on there. So yeah, we returned a 200 response. As you can see, the only thing that's updated here is the title and also the last updated. But most importantly, you can see that the publisher and release date have stayed the same. So hopefully we should see a new record in here. And we have. So let's have a look at that. We're going to go ahead and prettify that. So here you go. We've got this CUD down here. Create, update, delete, that stands for. And it says that it's updated. And literally the only change properties we've got is the one with the title. So it's from Friday the 13th, the game, to Friday the 13th. Lastly, we just want to check that the delete method works as well. So we're going to do a soft delete on that. Got our delete verb, our API endpoint. Let's run that. So it's returned a 200 response. We're not actually returning anything in the response, but let's just see if it's marked it as deleted first. As you can see, it's marked it as deleted there. Has it created a new record? Yes, it has. Let's again prettify the JSON string. So there we go. Here we go here. It's got deleted. The original was false and now it's true. So it's a soft delete.
So next time out, what we're going to do is we're going to build in functionality for ignoring properties. We're also going to build in functionality for references. So any entity that's related to another entity, we can actually log the data changes for that. Then we're going to have a look at seeing how we can actually use the ChangeData JSON to actually format the keys in that JSON into a SQL Server query. Lastly, we're going to have a look at testing as well, and we're going to use XUnit and discuss the importance of doing test-driven development in an application like this. Now for more articles, visit roundthecode.com, subscribe to my YouTube channel at roundthecode.com/YouTube, and follow me on Twitter, it's @roundthecode, and I will see you next time.